Thank you. Thank you. So yes, today I would like to turn this into a kind of fun live coding session where together we're going to solve a problem. So I don't have that many slides, but I wanted to start by just getting some sort of intuition from you for whether you have an idea when we should use LLMs or when we should probably not use them. So I'm going to start with something simple. Summarizing a paragraph of text. Do you think we should use an LLM for that? Yes, we should. Yes, I agree. Okay, next one. What do you think? Yes? Remind me not to buy games from you. No, probably not, huh? Okay, next one. How about this? Loan application. Should we use an LLM for this? No. Are banks going to listen to us? No, that's another. So that's too bad. Okay. Yeah. How about this? Yeah, probably. Yeah. How about this? Do you know this kind of puzzle? You probably do, right? You have to get the clues. So can an LLM generate this? No, yes, maybe. This is a bit complicated, right? Because there's probably areas of this that an LLM can do, like maybe generating clues or something. But there's also some, well, kind of algorithmic problems that you have to make sure that the characters match up and so on. So you can't probably, we're going to try that out in a minute, you can't probably just feed this into an LLM and get something that you want. Do you know, by the way, what this type of puzzle is called? Actually, I also tried to look that up. It's very interesting. There's actually this puzzle, nowhere this has a name except for one country in the world. Do you know which country that is? Netherlands, yes. I knew we were cool, but this is next level. In Netherlands, it's called a Philippine. A Philippine. I have no idea why. That's something for another presentation. But how about we build this together? Yes. Are you up for that? Yeah? Okay, good, because I don't have a plan B, so we're going to do this anyway. Okay, so before, does this work? I think so. Okay, so before we start coding away, maybe we should try just see if ChatGPT can actually generate this. I'm going to use the newest 4.0 model, so you know we're all state-of-the-art and everything. So let's say generate a word puzzle about Groningen. I don't know, the center column should form another word related to the topic. I should have to type that correctly. There you go. In Dutch, this is called a Philippine. I don't know why. Knowing the Dutch, it's probably something racist. Okay. Actually, I did look up where the word Philippine came from. It's on Wikipedia. Actually, Philippine is a type of almond which has 2 cores. And the idea is that if you are with a friend or something, you both eat one of those cores of that almond type. And then the next time you see each other, you're supposed to say, "Bonjour, Philippine." That's the explanation. It makes 0 sense.
In French.
Yeah, so I still have no idea why it's called a Philippine. Anyway, let's see what ChatGPT came up with. So we have some clues. This is, well, not that bad, I think. It's a very skewed center column. So clearly, this is not, if you just use ChatGPT for this, it's not going to be very reliable. Maybe in a few years when we have GPT-6 or something, it's going to be perfect, but doesn't work.
But it's correct, right?
Yeah, so I mean, you probably have to, it doesn't align them correctly, so that's an issue. And I also did a few other tests actually before this, and like this is, I think, one of the best ones. Mostly it just generates complete garbage. Like, for example, here, yesterday I also did one where, yeah, you get some, oh wait, this one, I think it was this one. Yeah, you get some translated Philippine text about Groningen, and it's like, it's completely lost. It's really completely lost. So let's solve this together then. I have my code editor here. So what do we need to do if we want to, let's say we're not going to create the whole interface, we just want something that generates this puzzle and prints it to the console, all right? So what do we need to do? What are the steps to generate a puzzle like this? Where do we start? Okay. Any other ideas apart from using ChatGPT? Let's be a bit creative.
First, get a topic.
Get a topic. Okay. Yeah. Okay. Let's define a topic. So let's say we want Groningen. Okay, we have a topic. Don't. Now, what are like? What would be the steps to create a puzzle like this? What do we need? Huh? Create a title. Yeah. Oh, that's good. Yeah. So there's a couple of steps going to be involved, right? We might want a title, like Copilot suggests. What are other things that we're going to need? The words for the puzzle, the rules. Okay. Yeah, we could generate those. Let's assume we know what the rules are. What do we need to actually display a puzzle like this? What information? A graphics library, yeah, yeah. Okay, a grid. If we print it to the console, let's just assume we have the character grid, so we keep it simple. Other things? Okay, you need a way to verify the generated puzzle as well. So of course we can go into like a whole rabbit hole of all those sorts of things. I heard somebody say we need a list of words, right? So we need that list of words that we're going to display. We need the solution. We need to know what the solution is. Yes?
Think of the solution yourself, then explain to ChatGPT, make the question with at least one letter.
Okay. Good, yes. So you're already thinking about how to link up these things. So if we like take a look at it, so we need a solution, right? Then we're going to need the words that match that solution, that each have a character from that solution. And then we're also going to need the clues in order to guess the words, right? Exactly, yeah, so that's actually very interesting. So it's actually the case for many types of puzzles that you start with the solution and then you work your way backwards. So you're going the other way around as solving it. So we start with the title. We need to ask for a solution. Then we need the words, and then we need the clues. There we go. So that's basically the steps. And then, of course, once we have that, we need to actually print the puzzle, right? So that's roughly what we need to do. Now, I only have even less than half an hour now, so not a lot of time. So I already did some preparatory work, obviously. So I created already a few prompts. So title prompt, a solution prompt, a prompt to get words, and a prompt to get the clues. And I'm using I'm not using LangChain or anything complicated for this. I'm simply using built-in Python functions for that. And as you can see in the main file, I have a chat function that we can give a string, and that is going to return a string. So that's our integration with, in this case, I'm using OpenAI's GPT-4. And I'll show you also near the end of the talk what that chat function actually looks like, because it does something interesting that we're going to apply later as well. So we have the puzzle, we have the prompt, sorry. And then what I've already done is created a simple class, so I don't have to type all of this stuff here while you're waiting for me. So that puzzle class, I'm using Pydantic, because then I can do things like this for default values, which is nice, and I also can turn this puzzle object into a dictionary or do some validation later on if we want to validate that the puzzle is actually correct. And then I have a generate function that generates a title and a solution, a list of words, and the clues. And these are simple calls to this chat function that I have this integration with OpenAI's GPT-4, where I substitute or I create the title prompt from the template. So for example, here I supply the topic. So if you look back at the prompt, you see that it's in there. So I can reuse these prompts basically. And then it does all of this work. So we generate the solution, words and clues, and I have some debug settings so that while I'm working on this puzzle, I can actually see what is being generated. And then it has a print method that for the time being only prints the title. So let's import. I'm going to move this here. Yeah. Yeah. Okay, so I hope this is loud enough. All right. That sounds great. Okay, so I'm going to import this puzzle game. And then let's remove these because that's already there. So I have a puzzle game object, and then we're going to generate a puzzle and print the puzzle. So let's see what this actually gives us. Oh yeah, I forgot to remove the pleasantries. Okay, so the solution is going to be Martini Toren. We get some words. And I didn't print those, but we probably also got some clues. So this is, seems to be working well. There's one issue though. Okay, yeah, that's maybe even better. There's one issue though, is that currently this time it worked. Actually, when I run this, we have a sort of reverse demo effect. Normally the demo effect is that something doesn't work. But the reverse demo effect is that something is not supposed to work and it actually works. So actually in about 3/4 of the cases this crashed. I can try this one more time. Maybe it crashes this time. Let's see. Probably it doesn't because this is the demo effect. But where it crashed is basically where it went wrong quite often is that it generated words, but they were not always matching exactly with the solution. So now, of course, it works again. So yeah, you just have to believe me on my word that sometimes this breaks. So one thing that you can do is that instead of generating, let's say, a single word for each character in the solution, you could also generate several words, right? And this is kind of typical of when you work with LLMs. So they will not always provide you exactly with the result that you want. So you have to build in some flexibility in order to still get what you want. So, and there's no reason why it's different from a human. I mean, if you ask a human to speak 100 words instead of 10 words, then this human is going to be a bit annoyed because it's a lot of work, but an LLM doesn't really care. So for an LLM, we can also ask it to generate, let's say, 10 words related to the topic. And then it's going to generate 10 words, but then, of course, we have to write a bit of Python code that cleans that up, because then we're going to get a much larger list of words, which probably will increase the chance that we will get something that is correct, but we have to do some cleanup. So this is often what you need to do when dealing with LLMs. So if we go back to the puzzle game, that means that instead of directly generating the words here, we need to add an extra step. So let's say that we're going to add a method here called filter words. And this is going to give us, in principle, we want a list of filtered words that matches the solution. So then the first step here is that we are going to store this in, let's say, all words, and then the actual word list is going to be a filtered list of words. And then here we can filter this. So now, yeah, this doesn't make any sense, obviously. What GitHub Copilot wants to generate, but now basically what we need to do is go through all the words that were generated. So this is passed as an argument to filter words. And then we simply make sure that we take the ones that, that match the character from the solution. So this I also already did, because I actually prepared this a little bit. So that looks like this. So here we have, we passed the words. Let me just copy that over so we can see how that goes. So here what happens is that we go through each of the characters in the solution, and then for that particular character, I'm comparing whether the character is actually in that word. If it is, I'm adding it to the total list of words, and then I break out of that. I'm also converting it to lowercase, because in some cases it might generate words with some uppercase characters, and of course you want to make sure that these are the same. And then in the end I'm just going to check that these things are going to be the same length, so that we know when things are going wrong. So the final thing that we need to do in order to show the actual puzzle is actually print it to the console. So how do we do that? What do we need to do to print the puzzle to the console?
Loop and align?
Yeah, we need to loop over all the words, print the words, and then probably we also need to print the clues, right? But the alignments, how do we do the alignment? How do we make sure that everything lines up so that there's a center column? Yeah, so we need like a special character in the middle to show like, hey, this is the center column. That's we can write an X for that or something, and then underscore for all the other characters. But how do we align them?
Prefix with white space.
We prefix with white space. Yes, you are a terminal builder. Very good. How much? Exactly. How much white space?
The index of the character in the word.
Yeah. So we need to first know, okay, so how much white space do we need? What's the maximum white space that we're going to need? What's the most white space that we're going to need? It's the highest index in the word, right? So if one word basically has is the last character and has like 10 characters before, it means we need to shift all the other words as well. So that means that the first step is that we need to determine what the maximum index is. So what we can do is, as a first step, we can create, let's say, a list of all the indices. Which is going to be, what we can use for this is a list comprehension. And what we can do is go through the solution, character by character, and through the list of words, character by character, and get the index from that. So we can actually use a Python function called zip for that. So I'm first going to write that. So we have zip of the solution and the words. And then we're going to get a character and a word in. And now what we need to do is get the index of the character in that word. So that's going to be, I think, let me check, word dot index of the character. Does this make sense? Yeah? Yeah, very good. So let's also turn word into lowercase, and let's also turn the character into lowercase. So this is what we're going to get. Yeah. And then we can simply create the max index, which is going to be this. So now we have the maximum index. So now what we can do is is this actually what we want? Ah. Now we're going to go through the words and the indices, and we can now print the word to the screen. So you see it already creates something for me, which actually does look kind of correct. And then it's going to print the padding and the word. So what happens here is that we take the difference between the maximum index and the index, and then simply print that. And then, okay, some white space. I'm just gonna listen to Copilot here. So, and then we're going to print the clues. So actually, that looks pretty good. I might actually finish on time. Okay, so let's see if that works. Oh, sorry, yeah. Okay, keeps coming up with Martini Torum. Might have to ask it to be a bit more creative. Takes a while because it generates more words now, obviously. Just in case GPT breaks or something, I also have a backup, which is another puzzle about Groningen and Eierballen and things like that. So let's see. Okay, yeah, so it did print it, but now the only thing we need to do is replace this by actually not printing the characters, but printing something else like underscores or empty spaces or something like that. But this is actually pretty close to what we want, so that's really nice. I have given the time, I'm not going to code the rest of this. This is basically a smaller detail, but when you want to print that, then the only thing you basically need to do in that for loop, so I've more or less the same thing here, is that you need to replace that word by X's and underscores, and this is basically what this line of code is doing. So, to recap from the LLMs, what you see when you use this, if you want to solve a problem, most problems are actually more or less like this type of puzzle where you can't directly feed it to an LLM. You need to decide on what parts an LLM is going to be good at and what parts, well, you can better just write some code yourself, right? And you also need to build in extra flexibility, like expanding the list of words or guiding an LLM a bit more into what you actually want out of it. Now, an interesting thing is that for this particular version, I followed a pretty traditional object-oriented approach. I think when I look at a lot of Python developers, this would be kind of a typical way of doing this, right? You create a class, you add some methods, and that's kind of how you work. What's really interesting is to approach it from a programming point of view a bit differently and see if you can add some functional concepts to this to kind of rewrite this code in a different way. And I also did a version that shows that. So, and that looks roughly like this. So I kept the puzzle class. Classes are still helpful, you know, they provide a structured way of representing data, so that's nice. But then most of the methods, they're now functions. So filter words is a function, which also means that it's much easier to test. This is actually a pure function, so that's really easy to test. Generating the puzzle now also is a function, so that's already something you can do. Doesn't make a big difference, but that's already something you can do. you also see that generate puzzle, in this case, gets the chat function as argument, just like before. And if you have a function that gets another function as an argument, that's also called a higher order function, and that's actually a really powerful aspect of functional programming. And I want to show you what this chat function actually looks like, because I didn't really do that yet. So if you remember, we simply created this in the beginning by calling something called chatter with an API key, right? So what does that actually look like? So if I go into the definition of that function, this is basically all it does. It gets an API key, you can optionally specify a model, and then returns something called a chat function. So this is a type annotation in Python. This is also a higher order function because it's a function that returns a function. And that's also quite interesting. So what we see here is that we define a function inside this function, and then that's the function that we return. This is called a closure, and that means that this function has access to the outer scope. So what happens here is that I create this AI client, which is a simple thing from OpenAI, and I pass the API key, and set chat request, because it's part of this chatter function scope, can access this AI client, even if you return it and then call it from somewhere else later. That's not a really powerful aspect of functional programming. That might be something else you could think about when you write software. Instead of just going for classes and methods, doing these kinds of techniques can also be quite helpful. But you can take this even a few steps further. So, for example, if I go back to my puzzle example. A vraag? Question? Sorry?
Time to wrap up.
Yeah. I'm almost done. Yeah. I have a second version here, which takes this a step further. It depends on you kind of how far you want to take it. But this is the same function, but now I'm using something called function composition. So you see in this first version that we simply call the chat function, and then, for example, here we do parsing JSON, filtering words. So this is basically a chain of function. So you could also do it a bit differently and use function composition, which means that you supply a list of functions and then you apply those one at a time. That's what this compose function does right here. I won't go into details right now. But then you call this compose function instead of calling all those functions in sequence. And that can sometimes be a bit shorter because you need less parentheses and things like that. And then you can go even crazier by then putting the compose call in another function and then call that function on whatever you need and then call that function at the end. So there's lots of layers that you can add to this to go completely insane with functions, basically. What I wanted you to take away from this is not that functional programmers are insane people, but that it can be helpful to not by default always go for classes and methods, but also think about applying this technique to your code. So I'm going to wrap up here. Thanks so much for your attention, and let me know if you have any questions.